In this module, we'll analyze the eigenvalue method. So let's look here at an example. We're going to apply the eigenvalue method to find the general solution of this system of equations. The first equation is x sub 1 prime, which is equal to x sub 1 plus 2x sub 2. And the second equation is x sub 2 prime, which is equal to 2x sub 1 plus x sub 2. Notice that the characteristic equation is, and you're going to maybe need to pause the video here and check this equation if you don't remember how to obtain this. Maybe even need to ask a question on the discussion board. But we're going to outline the steps here and not show all of the mathematics. So notice the characteristic equation is lambda squared minus 2 lambda minus 3, which is equal to 0. And you should be able to observe that the distinct real eigenvalues are lambda sub 1, which is equal to negative 1, and lambda sub 2 is equal to 3. Now notice we won't always have real eigenvalues. Sometimes we'll have complex eigenvalues. Sometimes we'll have repeated eigenvalues. And so you're going to want to know the forms of each of these type of solutions. But here we have distinct real eigenvalues. Now our eigenvectors, and again, we've not shown the mathematics, we're outlining that first you find the characteristic equation, then you find the eigenvalues, then you find the eigenvectors. Our first eigenvector, v sub 1 is equal to 1 and negative 1, and our second eigenvector, v sub 2, is equal to 1, 1. All right, we'll use this information here to then find the general solution. And the general solution is x sub 1 of t is equal to c sub 1 times e to the negative t plus c sub 2 times e to the 3t. So you'll notice our exponents here are negative 1 and 3, which correspond to our eigenvalues. And our second equation, x sub 2 of t is equal to negative c sub 1 times e to the negative t plus c sub 2 times e to the 3t. And you should see here that our coefficients match those of the values that we have in our eigenvectors. All right, well, we just found the general solution when we have two distinct real eigenvalues. We'll look for any other questions you might have as you work through the homework on the discussion board.